Hello students, and welcome back to another algebra video. So, today we start our work on chapter 7, so I'd like you to think about the following things. What do the following prefixes mean? Now remember, a prefix is something that comes on the beginning of a word, so like if I said retake your tests, re is the prefix of that word, and it typically adds a meaning to a word. I'm not an English teacher, but I do know what these prefixes mean. What do you think they mean? Pause the video and tell me what you think each of these prefixes, actually this is a suffix, but what do you think these mean? What do you think mono means? Bi, tri, poly, nomial. What do you think that these mean? Unpause the video for us to chat about it. So, mono, bi, tri, and poly are all Greek prefixes. Again, I'm not an English teacher, but I'm fairly certain about this. Mono typically means one. You might have heard about mono if in your history classes, perhaps, if you've talked about religion, you might have talked about monotheism versus polytheism. Bi, we have bicycles, two wheels, so bi typically means two. Tri, tricycles, of course, three. And then poly actually means many. So it's not necessarily four, could be more. Many. And then nomial, we're not 100% certain. So the reason I ask about nomial is because chapter 7 is all about polynomials. And so we know what poly means, but what does nomial mean? Now, we think that nomial comes from the Latin nomen. So it's funny how poly is Greek, but nomen is Latin. And nomen in Latin means name. So polynomial might mean something like many names. Now, that might not make sense right now, but I want you to keep it in mind when we continue to talk about polynomials, because I think you'll see how it fits in. All right, so let's jump right in to chapter 7 and to section 7.1. So, 7.1 is all about adding and subtracting polynomials. We're actually going to do that in the next video. First, we need to know all about polynomials. There are 8 sections in chapter 7, 7.1, 2, 3, 4, 5, 6, 7, 8. So we're going to be talking about polynomials for a long time. So today we're just going to break down everything you need to know about polynomials. So our learning target is that you know what polynomials are, and the success criteria is that you can find the degree of polynomials and you can classify polynomials. So lots of vocab words today. We're going to find out the degree, we're going to learn how to classify polynomials, lots and lots of information about polynomials. So, first off, we need to know what a monomial is. So a monomial is a number, variable, or a product of a number and one or more variables with whole number exponents. You must have whole number exponents. If you see x to the 1/2, that is not a monomial, not a polynomial. So, all of these are examples of monomials. -5 is just a number, but it is still considered a monomial. Here you see 0.5 times y squared. Here there's only one variable, y, still a monomial. Here you see we have x squared and y, so we have 2 variables. And we have a 4 here, so we have a number and 2 variables. 2 variables. So that is still a monomial, because they're all being multiplied together. So as long as you have things touching like this, the 4 is touching the x squared, which is touching the y, it is a monomial. Now you cannot have a variable in the denominator. This is not a monomial. Now if you have a number in the denominator, that's okay. This is okay. This is not. This is good. This is bad. So you cannot have a variable in the denominator, and you cannot have a fraction in your exponent. But otherwise, as long as everything is touching, doesn't matter if it's just a number, doesn't matter if it has variables, it is a monomial. And you actually don't even need a number in order for this to be a monomial. What if I just have y squared? Well, that's like 1 times y squared, so y squared is still a monomial as well. Okay, so we need to be able to find the degree of a monomial. So you saw in the learning target and the success criteria, we talked about being able to find the degree of a polynomial. And if you can find the degree of a monomial, you can find the degree of a binomial, a trinomial, a polynomial. All of them. So we're going to start nice and simple with finding the degree of monomial. So we talked about what a monomial is. Now the degree of a monomial. The degree of a monomial is the sum, and remember that means add, so the sum of the exponents of the variables, plural, all the variables in the monomial. The degree of a non-zero constant term is 0. So whenever you have just a number, we call this a constant. We call it a constant. And the constant 0 does not have a degree. So, I know that might have sounded a little confusing. Let's break it down a little bit more. So, the monomial, I got rid of my arrow. The monomial 10. Anytime you have a constant term, if you have 10, if you have 13, if you have -4, the degree of all of these is 0. Because 10, this is like 10 times x to the 0. Because remember, from last chapter, anything with the exponent of 0 is just 1. So this is 10 times 1, which is just 10. So anytime you see a number that's just 10 or just 13, remember that it's like having x times 0 attached to it. And so when we talk about the degree, we want the biggest exponent. So here, the biggest exponent is 0, and that's why the degree is 0. So next example, if we have 3x, remember this is like 3x to the 1. Anytime you see an x or a variable, you can think of it as the variable to the first power. It's the same thing. 3x to the 1 is the same thing as 3x. So anytime you have, you just have a variable, the degree will be 1. Now, making it a little more complicated. Now we have 1/2 times a times b squared. So now we have 2 variables. So if we want to find the degree, we actually have to add the exponents of both of our variables. So here we have a to the 1, and we have b squared. So that's where this 1 comes from, and this 2 comes from. So when we take this monomial, 1/2 ab squared, the degree is actually 3. Now, so that's if you have multiple variables, and in fact, if I had x squared times y times z cubed, the degree of this would be 2 plus 1, because the y has an exponent of 1, plus 3. So the degree of this monomial would be 6. Okay, so that's what happens if you have multiple variables. If you just have one variable, this last example right here, -1.8 times m to the 5th. If you just have one variable, you just take the exponent of that one variable. So, 5, because it's m to the 5th. So those are nice and easy. Okay, we talked about some things that are not monomials. Let's go over a few more. 5 plus x is not a monomial because you're adding two things together. Remember, mono means one. Here I have 5 and I have x. That's 2. I have a 5 plus an x. So that's not a monomial. That would be a binomial. And we're going to talk more about those in a little bit. We already talked about how you cannot have a variable in the denominator, so that's not okay. We actually didn't talk yet about how a monomial cannot have a variable exponent. So this says 4 to the a. You cannot have a variable in your exponent. So all of these things are not okay. And the variable must have a whole number exponent, so you cannot have negatives. So no negative exponents. Okay, all right. I know that was a lot of information. If you need to rewatch this portion and like pause in between it to understand what we're saying, please do. And make sure that you have taken notes on this. So if you didn't take any notes, please go back, rewatch it, take some notes. We're going to talk about polynomials for the entirety of Chapter 7. So if you don't know what's going on here, polynomials are going to be really confusing for you. The next chapter is going to be really confusing for you. So, example 1. We are going to take what we just learned in that last slide, and we're going to find the degree of monomials. So, first, I have 5 times x squared. Now remember, the degree comes from the exponent of the variable. Here, my variable is x, and it has an exponent of 2. So the degree is 2. And there you go. All right, let's do some more examples to solidify our understanding. So here, I have negative 1/2 times x times y cubed. So I have a variable here, x, and the exponent here is 1, because remember, just x to the 1 is the same thing as x. So I have 1 plus, I have y here, which has an exponent of 3. So I need to add these together, and I get 4. So this monomial has degree 4. Okay, if you're feeling confident, pause the video now, try C and D on your own. If you're like, no, please don't leave me, that's okay. Do the problems with me. Just keep the video rolling. Okay, here I have 8x cubed times y cubed. So this variable's exponent is 3, y's exponent is 3, and when I add them together, I get 6. So this monomial has degree 6. All right, and lastly, we'll look at -3. Remember how we talked about how numbers by themselves are constant. So this is called a constant because it's just a number. And that n looks funny. Constant. Okay. And whenever we have a number, we can think of this as -3 times x to the 0. Because remember, anything with an exponent of 0 is just 1. And -3 times 1 is just -3. So this is like -3 times x to the 0, and the exponent of the variable is 0. So this has degree 0. And if this part confuses you, thinking about, wait, a normal number, like just a constant number, has a variable with the 0, if that's confusing to you, all you need to remember is that if it's a number, if it is a constant term, degree 0. If you just have a number, it's degree 0. That's all you need to remember. Okay, alrighty, so there you have it. Our first example, finding the degree of monomials. Let's check. We had 2, we had 4, we had 6, and we had 0. So yay! Yay. All right. We're going to move on to some more information. I told you we were going to talk about binomials, trinomials, polynomials. That's why we talked about it in the entry task. So, a polynomial is a monomial or a sum of monomials. So, like this down here at the bottom, when you add a ton of monomials together, we call it a polynomial. And we call each of the things that you add together, we call terms. This is the part where we said polynomial. Polynomial means many names, when we thought it meant many names. We think the names portion of it refers to the terms. So, when I said like many names might be confusing, we think of it as many terms because we're adding up. So each of these is a term. Everything that's added together, everything between the pluses and minuses, we call a term. And so that's where polynomial comes from. Many names, many terms. So a polynomial, and a monomial is considered a polynomial. A binomial, it's a polynomial. It's just a more specific type of polynomial. So all of these are polynomials. They're just even more specific than polynomial. A binomial has two terms, 5x plus 2. 1, 2. Binomial has two terms. A trinomial has 1, 2, 3 terms, and a polynomial has 4 or more terms. And a monomial, again, is like just by itself. Something like this is a monomial. Okay, so the degree of a polynomial is the greatest degree of its terms. I'm reading right down here. The degree of a polynomial is the greatest degree of its terms. So here, if we look at this binomial, 2 has a degree of 0, and 5x has a degree of 1. The greater degree, or the bigger degree, is 1. So the degree of the entire polynomial is 1. Okay. We're going to talk more about that later, so don't worry. A polynomial in one variable is in standard form when the exponents of the terms decrease from left to right. So an example of that is this trinomial. We have degree 2, degree 1, and degree 0. So see how it goes 2, 1, 0. We count down from left to right. So if this were written like 2 plus x squared plus 5x, this is not in standard form because it goes 0, 2, 1 instead of 2, 1, 0. Oops, I dropped my pen. Okay, and we're going to talk more about that later too. This is all just an introduction. So, when you write a polynomial in standard form, the coefficient of the first term is the leading coefficient. So we've talked about the word coefficient, goodness, all year long, basically. Remember that a coefficient is any number attached to a variable. So when we have 2x cubed, 2 is a coefficient because it's in front of the x cubed. When we have negative 5x, negative 5 is a coefficient because it's in front of the x. So the leading coefficient is just the first. You write the polynomial in standard form, and then it's the first coefficient that you have. So if all of this was confusing and you're like, Miss Dodge, I don't know what's happening, don't worry. We're going to talk about these things more. Please make sure that you take some notes on these, though. Binomial, trinomial, all of the bold words. All the bold words on here you want to put in your notes. Okay. And now let's get to our next example. I told you that we were going to talk more about degrees, more about polynomials in standard form. We're going to do that. So here we are asked to write 15x minus x cubed plus 3 in standard form. So, and then we will identify the degree and leading coefficient of the polynomial. So first, let's write it in standard form, then let's identify the degree, and then let's identify the leading coefficient. So we can split problems up into more manageable chunks. Okay, so 15x minus x cubed plus 3. We want this put into standard form. So remember, standard form needs to go from the biggest degree down to the smallest degree. So your exponents, basically. You need your biggest exponents over here, your smallest exponents over here. So when I look at this polynomial right here, I immediately see that 3 is the biggest exponent. So that's going to go first. Negative x cubed will go first. Then, 3 doesn't even have a variable for an exponent. But 15x, remember this is like 15x to the 1. So 15x will come next. Now, in our example on the last slide, we had the 2, 1, 0. You can skip some. It's okay if you're like, there's not an x squared here. That's okay. There doesn't need to be an x squared. You can skip some. It's whatever terms are in the polynomial you start with. So now we have plus 15x, because that's like x to the 1. And now remember the degree of a constant term, like 3, is 0. So 3 is our smallest term. Or excuse me, the term 3 has the smallest degree. So now we have written it in standard form. It goes 3, 1, 0. So biggest number over here, smallest number over here. Woohoo! That's part 1 done. We have written the polynomial in standard form. Now let's identify the degree of the polynomial. New color. The degree. So remember that the degree of the polynomial is the first term in the polynomial. It's the degree of the first term. So the biggest exponent, basically. So we have this polynomial has degree 3 because our first term, the negative x cubed, has an exponent of 3. Okay, let's get a different color in here, and now we're going to find the leading coefficient of the polynomial. So the leading coefficient is, remember, our first term is where we get the leading coefficient from the first term, and the coefficient, so let's see, negative x cubed is our first term. Remember, the coefficient is the number in front of the x cubed. So we have negative, and remember there's always an imaginary 1 here. So the leading coefficient is negative 1. Okay, and we did step 1, we did step 2, and we did step 3. So we have finished this problem. We're going to do another one after we check our answer. Write the polynomial in standard form. The degree is 3. Oh yeah, so when they say degree is 3, they're talking about each of these terms. So the greatest degree is 3, so the degree of the polynomial is 3, and the leading coefficient is negative 1. So we were right. Okay, so if you're like, Miss Dodge, this has gone way too fast, we're going to talk even more about classifying polynomials. And we do that, we're going to write them in standard form. So that's step 1, is to write them in standard form. Then we're going to identify the degree and classify them by the number of terms. So monomial, binomial, trinomial, etc. So we're going to put everything we've talked about together right now. So first, we are going to write each polynomial in standard form. So this only has one term. Remember, when we say write it in standard form, we mean, oh, this one goes first, this one goes second. But there is only one term here. So we're already done. This is already in standard form. -3 z to the 4th is already in standard form because it is a monomial. Monomials are already in standard form because there's only one term. Okay, but now we need to identify the degree. And remember, we did this in our first example, finding the degree of monomials. This is just the biggest exponent. So that is 4, because we have z to the 4th. Okay, let's move on to the next one, new color. So write this in standard form. 4 plus 5x squared minus x. So here, 4 has a degree of 0 because it's just a number. 5x squared has a degree of 2, and -x has a degree of 1. So now we're going to write the biggest exponent over here, the smallest exponent over here. So we have 5x squared minus x plus 4. See how this exponent is a 2, this exponent is a 1, and this exponent is a 0. So we go from biggest to smallest. Okay, and now how many terms does this have? This polynomial has 1, 2, 3 terms. So this makes it a trinomial. And we want to know its degree. So that's the biggest exponent in the first term. So the first term, the biggest exponent is 2. So this has degree 2. Okay, one more. We have 8q plus q to the 5th. So here we have a degree, whoa, not degree 0, excuse me, this is like q to the 1, so we have a degree of 1, and q to the 5th clearly has a degree of 5 because its exponent is 5. So now, remember, biggest exponent first, smallest exponent last, so we have q to the 5th plus 8q, and that is in standard form. Now, this has 2 terms, q to the 5th, 8q, 2 terms, so this is a binomial, and the biggest exponent is a 5. So our degree is 5. Okay, let's check and make sure we were right. Standard form, beautiful, degree 4, degree 2, degree 5, and monomial, trinomial, binomial. Beautiful! Okay, that is all I have for you today. So we're going to be talking about these things throughout the rest of the chapter. So please make sure that you understand them, and if you have any questions at all, please phone a friend, talk to your teacher, email me, whatever you want to do. But it is very important that you understand everything in this video. Some practice problems, if you'd like to try them, are these problems. They are in your ebook, and of course they might be different than the homework that your teacher assigns. So make sure you still do your homework if you do those problems as well. Okay, and now our launch, just like usual. Oh, it should say launch up here, like usual. Our launch is from Shel Silverstein, which is a character from a movie, TV show. It says, how much good inside a day? Depends how good you live 'em. Now, I know that's kind of slang, kind of not proper English, but still has a really good meaning. And what it means, it's asking how much good is inside of a day. It depends on how good you live them. And of course, this should be how well you live them, so that it's hard. So what I'm trying to say is sometimes it's hard to understand what people are trying to say. But Depends on how well you live them. So, if you want to have a good day, live a good day. How much good you have in a day depends on how well you live the day. So if you want to wallow in, oh, it's just such a bad day. I stubbed my toe this morning, and then I forgot to put cookies when I packed my lunch, so I just didn't have dessert. And then Corey looked at me funny across the room, and now, and I had to do chores when I got home. Like, you know, you can be sad about everything that's happening, or you can focus on the positive things throughout the day. That seems to be a theme of launches we've had, focusing on the positive. So if you focus on the positive and you live, if you live them good, if you live a good day, you'll have good days. So that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.